Hello, everyone, and we are at such a big lesson and sequence of lessons coming up that are going to be very useful to us in the future. So this one here, we're going to be talking about the product rule, and you're going to understand this by the end of this, and you're going to have something memorized soon, and it's going to be fantastic. Now, 4 stars of importance. This is very big. You'll be using this a lot. And we're going to look at through 3 functions here, all right? So we have 3 functions here, and I just want to take the derivative of all 3 of them. So the first one here with what we know, if we want to take the derivative of x times x plus 3, well, we would probably first have to rewrite that as x squared plus 3x. And recall, and I'll write this up here, that the derivative of a polynomial a x to the n will be equal to a n x to the n minus 1, where you can multiply the first 2 and then subtract the exponent by 1. So what we get here is 2x plus 3. Moving on to this one here, we have a function x plus 10 times x plus 5. Well, we'd have to multiply this out first and get f of x equals x squared plus 15x plus 50. And then we could take the derivative of that. Sorry that my spacing didn't work out. I thought I'd need another line, but I guess not, and get 2x plus 15. And then this one here, we'd have to multiply that one out and get f of x equals, this one's a little bit more tricky, so that's going to be negative 3x to the 5th plus 3x squared minus x to the 3rd plus 2, and the derivative of that function would be negative 15x to the 4th plus 6x minus 3x squared. And there you go. And that's great, but is there an easier way? Yeah, there actually is. And this is going to be the product rule here. Now, I know the book says, do you see any patterns? And I don't know if you'll see it, but after I show you this, we're going to show you how this really works. So here is the product rule, 4 stars of importance. The product rule. Okay. And that is simplified in a way. If you have a function f of x, which is equal to, and there's 2 functions that make it up, g of x times h of x, so there's 2 functions multiplying each other, then f prime of x, if you want to take the derivative of that function, well, what you have is it's the derivative of the first, leaving, I'm sorry, I messed that up. It's the derivative, the first, times the derivative of the second, plus the second times the derivative of the first. And in words, it is the first times the derivative of the second plus the second times the derivative of the first. And that's what that's saying there in words. And now what's important is, yes, I know we might be doing this virtually or in person, depending where you're at, but it's important that you know this, and this phrase sticks in your brain for years to come, and you say, man, why do I memorize this of all things? And don't worry, it's going to be so useful to you. So say it with me. The product rule is the first times the derivative of the second plus the second times the derivative of the first. I'm even going to put a text box up to my left, helping you follow along with me. The first times the derivative of the second plus the second times the derivative of the first. Say it a lot, say it in your head, memorize that, and it's going to come in handy so much to you. Now notice how we can apply these here. Okay? Now we're going to do it in red to see this. So the product rule. So say we had that same function, x times x plus 3. Well, here we have 2 functions. You have x, which imagine that is g of x, and you have the second, which is h, which we'll call h of x, x plus 3. So the product rule states that to get the derivative of this function, there's 2 functions multiplying each other. So it's the first times the derivative of the second. Well, what's the derivative of x plus 3? Well, that's just 1. Plus the second times the derivative of the first, which the derivative of x is just 1. And what we get if we clean this up is we get 1 times x, which is x, plus x plus 3. And simplified that. Notice how we get 2x plus 3, the same thing we got up here. You might be saying, wow, that's great, but that actually felt easier. Maybe it is sometimes, but let's see what happens on the second one. So we had the function x plus 10 times x plus 5. And we want to multiply these out. I'm going to draw a line to separate this. So the derivative here will be the first times the derivative of the second, which the derivative of x plus 5 would just be 1, plus the second times the derivative of the first, and the derivative of x plus 10 is just 1. So what we get here is x plus 10 plus x plus 5 simplified gives us 2x plus 15. And notice that's the same thing we got up here. Woohoo, product rule. And again, you might think, man, okay, I'm starting to get it, and that's great. And let's look at the third one here. And this, is another example where maybe you can multiply it out, but the product rule is very nice here. We have two functions multiplying each other. Let's find the derivative that way. So it's going to be the first times the derivative of the second, in which in this case it's no longer 1. The derivative of negative x to the third plus 2 would be negative 3x squared, plus the second, and I'm running out of room, so mine looks sloppy, I'm sorry, times the derivative of the first, and the derivative of 3x squared plus 1 would be 6x. And if we clean this up a little bit, we would have f prime of x is equal to, multiplying that out, we would have negative 9x to the fourth minus 3x squared minus 6x to the fourth plus 12x. And putting this together, we would have f prime of x equals negative 15x to the fourth plus 12x. Uh-oh, I made a mistake. Minus 3x squared. What was my mistake? Plus 12x. Should have been 12x up here. 3x to the fifth plus 6x squared minus x squared plus 2. We get plus 6x. The second times the derivative of the first, which would be 6x. Negative 6x to the fourth plus 12x. Hey, what was my mistake here? Can anyone spot it? Where was it now? So we multiplied that out. And I believe that's all correct there. Because we get 3x to the negative 3x to the fifth plus 6x squared. Oh, that is my mistake. So this wasn't right up here. This should have been plus 6x squared. And then that would have brought down here as, when I take the derivative, then I would have had a plus 12x. And you might have caught that way before I did. But that's okay. I caught it now because I used the product rule. Woohoo! Right? And I'm not going to redo this video, so you had to watch me suffer through that myself. And that's okay. But there it is, the product rule in action. Let me do one more example with you, similar to what you'll see in your work. But again, that you just want to say to yourself in your head over and over again. The first times the derivative of the second plus the second times the derivative of the first. All right. So let's do the product rule in this last example here, where we're going to do one just like your problems to see how this looks. And we have here, let's do, say, b. So what if we had to do a function of 5 over x minus 8 squared? I know you don't see it yet, but I'm going to go right back to my paper so you can see it. Now, how can we apply the product rule here? Well, we can write this as two functions that are multiplying to each other. We can write it as 5 times x minus 8 to the negative 2. Now, applying the product rule, we'd have that the derivative is equal to the first times the derivative of the second, which is going to be negative 2x minus 8, plus the second times the derivative of the first, and the derivative of 5 is 0. So cleaning this up, what we're going to have is the derivative of this function is negative, that should be to the negative 3, I apologize, negative 10 over x minus 8 to the third. And there's the derivative using the product rule, where we wrote it as two functions multiplying to each other. So, hope that makes sense to you. I hope you said it a lot. One of your assignments is actually to make an audio clip or video of yourself saying this right here. So I know for sure you're saying it and memorizing it yourself. All right. If you have any questions, don't hesitate to reach out to me. Bye-bye.